there is someone who asked, what happens when it is a negative? What do we do when we have negative indices? If your power is a negative, what happens? Actually, this is the simplest of all, because there is no working out. You just automatically know once it's a negative, this is what you need to do. So when we have negative indices, this is what we are saying. There are times when expressions or the expression has a negative indices. But remember, indices, they are powers. Indices are powers. So once you have that expression and it is having a negative indices, what do you do? Okay, negative. For example, when you look at this, for example, you can be given a to the power negative 2. Okay, a to the power negative 2. Now, when it is a negative, what you are supposed to do is very, very simple. If you remember our third law of indices, I want someone to remind us the third law of the indices by show of hands. I want the first person to raise up the hand. The third law of indices. Yes, Edina Namatov. Our third law of indices.
The third law of indices
Yes.
states that when the integers are multiplying, when the base is powered inside, then it has the brackets.
When you have
we just multiply
and it has the power like this, what do you do?
We multiply n times.
We get a times the
n times m.
Good.
M.
Good. Thank you. Now, another person to give us the second law of the indices. Another one to give us the second law. What did our second law state? Someone to raise up the hand. JB. JB. Yes, JB.
Yeah. When dividing index numbers with the same base, subtract the powers.
Give us
example, a to the power m divided by a to power n
will be equal to
a to power m minus n.
M minus n. Good. Thank you, JB. Now, we are building on from here. Now, from our second law of indices, okay, it is what we are building on. You see this law here? It is what we are building on to solve this one here. So we know that this one, you see, when you have a to the power, a negative 2, this one is the same as you saying a. Remember we said a, it's the same as saying a to the power 0 out of a to the power 2. Okay, divide, it's like saying a to the power 0 divided by a to the power 2. That is what we have. For example, this is what we are doing. That if you have a to the power negative 2, it's like you are saying a to the power 0 out to divide by a to the power 2. So this is you the same as saying a. Remember when you said when we are dividing numbers with the same base, we subtract. So this is why we are having 0 minus the 2. Okay, and when you say 0 minus 2, this is equivalent to a to the power negative 2. We are working it backwards. So therefore, this a to the power negative 2 is the same as this one. But remember, what did we say? Any number to the power 0 is what? Any number to the power 0. What is that? Who can tell us this? Any number to the power 0 is, any number to the power 0 is, Trevor? Yes, Trevor?
It's 1. Any number to the power 0 is 1.
Good. Thank you. So any power to the power 0 is 1. That is one thing we should be knowing. Good. So therefore, we substitute this one here. You see why there is this? What was the subtopic before? The subtopic before this, we're looking at powers, indices with the fractions, fractional powers. Okay, so we are saying this is, so we substitute here. So this will be equivalent to a to the power negative 2 will be equal to, we substitute here with the 1. So we shall say this is 1 out of a to the power 2. Okay, so this is what we do with the negative. This is what we do with the negative indices. When any power is raised to a negative indices, we use the second law to solve it. And by so doing, we shall make it as a fraction. We shall have 1, the negative will be the fractional part of it, and that's how we shall come to it. So therefore, when you're solving a negative, wherever you see a negative, we are going to see more examples here. Whenever you see a negative, it means that this will be equivalent to, as we said, it is equal to a to the power that. So therefore, that's what we have. Therefore, a to the power negative 2 is the same as 1 out of a squared. I hope I've made that a little more clear on that. Okay, some people's hands are up. I hope they are not asking to answer a question. Let me ask Kakai. Kakai, can you unmute? Kakai Irene? Kakai Irene, are you there? No. Yes, Doris?
Yes, teacher.
Your hand is up?
I have no question.
All right. Thank you. So, who? This is Doris? What are you not understanding?
From the second law of indices.
Okay. So we are saying that to work out this, we are basically using our second law to be able to come up with our answer from here. And remember our second law, we were saying that when you have a to the power n divided by a to the power m, okay, so what do you do to this? We said you subtract the power. So therefore, we will have a n minus the m. So by doing the substitution, that is how we are coming to this. That's why we are saying end up with -2. So we say it's the same as, and remember in one of the illustrations I gave you, I told you that any number that is raised to the power 0 is always 1, and that's why the 1 is coming. That's why the a to the power 0 is being substituted with the 1, and therefore we say it is 1 out of the 2. That's how we are coming to that given answer. Now, maybe let's see, work out something else as well. Let's work out something else, as I'm going to come back to this other row as well. For example, let's look at this. If we have 4 to the power -2, 4 to the power -2, this one is the same as saying 4 divided by 4. This is the power 0. This is the power this is the power 2. Okay, this is the power 2. Okay, so therefore, this, remember we said this is like saying 4 to the power 0 out of 4 to the power 2. And we know that any number raised to the power 0 is always 1. So this will be equivalent to 1 out of 4 to the power 2. That is this. That's how we are working it out. Okay. So whenever you see a negative power, it means you're going to create a fraction, and that fraction will not have the negative. That's something we need to get in our minds as we are working out, that once you have a negative power like this one, okay, when you're solving, your result is going to be a fraction, and that fraction is not going to be having any negative because the negative has been catered for within the fraction. Okay. Yosia has a question. Yes, Yosia. Yosia Sewachirianga. Yosia, are you there? Yes, Yosia. Your hand is up. Okay. Logo say Anita. Jonita.
Sir, I have just joined us, requesting you to repeat, like I've just joined.
Okay. Okay. Josh. Yes, Josh.
Excuse me, sir. I'm requesting for a class code that enables me to access into the Google Classroom.
Okay, we are going to do that at the end of the lesson. Remind us at the end of the lesson.
Okay.
Thank you. Kasule? Yes, Kasule? Kasule Elijah, your hand is up. Okay. No. So members, those who have just joined us, we are looking at negative indices, or negative index numbers. What do we do with the negative? It's what we are doing. So once we are asking ourselves, when you have a number that is raised to the negative power, how do you solve it? First of all, to simplify it, we say this number has been generated by saying, like for example, this one, it has been generated in a way that you have 4 to the power 0 divided by 4. Now, when you divide this one here, you come to this one here. This is what you come up with. Your result is this. So it's like we are now expanding it. Yeah? We are expanding this one here. So you'll have 4 to the power 0 divided by 4 to the power 2. So just, whenever you have a negative power, you have some number which is the power 0. Okay, you have some number which is to the power 0. So therefore you divide. Then the other one is a positive one. So this is the same as you saying 4 to the power 0 out of, this is division. This is the same as this. That's why you say it is equal to. It's the same as 4 to the power 0 out of 4 squared. So this will be equivalent to, remember we said any number to the power 0 is 1. That's why we are substituting this one here up here to do with the 1, and we are having it here out of the 4 squared. So whenever you have a negative power, you always have this, you'll always have a fraction, and that fraction does not have a negative. Okay. Let me have someone who has understood this. We are going to work out this next one here. I want someone to work out. Nyombi. Yes, Nyombi. Are you there?
Yes,
Nyombi?
teacher. Yes,
Your hand
teacher.
has, yes, your hand has been up. You have a question?
Yes, I had a question.
Yes.
The question was 4 to power negative 2. But for you, you had said that when you were calculating, you told us that it is 4 to power 0 divided by 4 to power 2. I didn't understand that.
Do you remember our second law?
I wasn't there.
Oh, you were not there. You didn't see. Now, you didn't check our second law. Now, did you check the notes? Did you get the notes?
Yes.
Now, when you go through those notes, please read through the second law. When you read the second law, it will tell you that when you have any number with the same base and you're dividing the numbers, what do? You subtract the powers. That is where we are coming to this one here. That's where we are coming to 4 to the power 0 divided by 4 to the power 2. Now, when you do this, when you divide this one here, using this law here, it is the same as saying 4, 0 minus 2. What is 0 minus 2? Nyombi?
Yes, sir.
What
yes,
is 0
sir.
minus 2?
0 minus 2. It is 2. It is 2.
Are you sure? Sure? 0 minus 2.
It is negative 2, sorry.
Good. So you'll get 4 to the power negative 2. And that's how you are coming to this one here.
Yes.
Listen? Yes. So we are using the second law. That's how the second law is applying. Yeah?
Yes, sir.
Yes. So in so doing, that's why we are having 4 to the power 0 divided by 4 to the power 2, whereby we are saying 4, 0 minus the 2. So you come up with the same thing. That's how our second law applies. Please, when you go through those notes, you see the same thing.
Yes, sir.
Okay? Thank you.
Yes.
Okay, Denise. Where is Denise? Denise, you have a question? Denise, Anne?
Teacher, you've said. Teacher.
Yes, we are hearing.
That 1 over 4 to the power 2, negative to the power 2, is the same as 4 to the power negative 2. But if you calculate 1 divided by 4 to the power 2 is 0.0625.
No. We are not dividing. This is indices. We are not dividing. Okay? Here we are simplifying in terms of negative indices. Are we together? We are dividing in terms of negative indices. That's what we are doing. We are not saying get 1 divided by 4 to the power 2. No, we are not doing that. Okay? In indices,
and also I've lost your screen.
Okay. All right. Okay. Now I want someone for us to work out this one here. I want someone to work out this one here. Maybe you can share with us what you can do. Who's working? Okay, let me have someone. Hakim Bwire, are you there? Hakim?
Yes.
Hakim, huh? This is Hakim?
Yeah.
Are you seeing our screen properly? You're
Yes.
seeing our screen, eh?
Yeah.
Now, can you solve for us this one here in terms of solving that?
Teacher, I just wanted to ask.
Start.
Does it mean that if you have 1 divided by 2, 1 out of 2?
1 out of 2?
Yeah. Does it imply that, does it mean it is equal to -2?
That it is equal to -2?
Yeah.
No.
According to indices.
No. It is not this. Actually, you would even say it's maybe equal to 2 power -1.
Okay.
It is not -2, it is 2 power -1. According to indices, that is what it can be.
Yeah.
Yes, it is not -2. Okay. People have questions here. Shalom. Please let's ask so that we get this clear. Okay, Trevor wants to answer. Trevor? Okay, Trevor, are you there?
Yes, I'm here, teacher.
Good. Can you now?
Okay, as I believe, we should first prime factorize. We should first prime factorize 64.
So 64 is equal to.
Let me see. 64. Yes, 64. You first divide it. The first prime factorize is 2. You divide the factor of prime factorize is 2 is equal to 32. When you divide by 2, it's equal to 30. Then again, when you divide 32, it's equal to 16 by 2. When you divide 32 by 2, it's equal to 16. When you divide 16 by 2, it's equal to 8.
This is 32. I think this is what you're doing, yeah? Is this what you're doing?
Yes.
It is 8.
This is 8. Then divide by 2.
4. By 2.
Then divide by 2 is equal to
2. Then by 2
1
is 1. So 64 is the same as 2 to the power
6.
The power
6. 2 to the power 6. 6. Yes.
Okay. Good.
Then you put it in brackets. Like put it in brackets.
You
then put in brackets to power negative.
So this is the same as 2 to the power 6 into brackets. Power negative 2
out of 3.
Good.
Then you like multiply. Then after that you multiply the power with 3.
Correct. So following our our third law, we shall have 2 to the power 6 times -2 out of 3. Correct?
Out of 3.
So by this will be 1. This will be what? 2.
2. Yes.
Good.
Then answer will be 2 to the power -4. 2 to the power -4.
4.
-4. Then the correct answer is 1 out of 2 to the power 4.
So this will be equivalent to 1 out of 2
to the power 4.
To the power
4.
Thank you, Trevor.
Yes.
Good.
Yes.
Okay. I want someone who has not understood this part here, how Trevor has come to the answer. Thank you so much, Trevor. Ernest. Ernest, are you there? Ernest is not there. Atino Ashley. Please, you can also send your questions through the messages. I can also read them. Some of you are.
Teacher.
Yes.
This number for 4 to the power -2, where we had got our answer as the 1 out of 4 to the power 2, right? Teacher, why don't we also, whatever this 4 down, 4 to the power 2, why don't you also multiply 4 times 4 so that you can get 1 out of 16?
Pardon?
As in you left your number like 1 out of 4 squared. Why didn't we, expand this number? 4 squared so that you can get 1 out of 6.
I've got your point. Actually, you are not supposed to do, when you say 1 out of power 16, 1 out of 16, this is what you wanted to say. But we are leaving our answers in the power form.
In the form.
Okay. Yes, we are leaving our answers in the power form. You
so
maintain
it's
the powers.
appropriate to leave it
So
now
what
how
you
it
do,
is.
the appropriate way, actually, what you do, you'd maybe say, you see this 4 here. This 4 is the same as 2 to the power 2, right?
Yes.
You could also maybe do this. This can also work. This is okay. This can say this 2, this 4 is the power 2 in brackets. These are that you multiply these powers and you remain with the 2 to the power 4. Still out of 1, but leave your answers in the power form. Okay. Don't solve it out. Leave your answer in power form because we are dealing with indices. Indices are powers. Okay. When you again solve, when you multiply and get something else, it means you're not dealing with powers you now. Okay.
Okay, teacher.
All right. Thank you. Another person is someone who Kasule Elijah, your hand is up.
Sir.
Yes. Yes, Elijah. Kasule Elijah. Elijah is off. Yes.
I was asking you that.
You're breaking?
If you,
yes.
Yeah, as you have got that answer 1 out of 2. So are you hearing me?
Yes, we are hearing you now. Yes, we are hearing
as
you.
You have got 1 out of 2. Then that 4 you put it on top of 2. That power
2 to power 4. Yes.
You put it on top of 2. Yes. You put it on top of 2. I have said that. I have said that, sir.
Yes.
Sir.
Yes, are you talking about the second question?
Yeah, I'm talking about the second question. That one.
Yes.
As you say, it is you power that power 4 you put it on top of 2 only.
Yes, only on 2. You don't put it up, it's only down. Yes, you don't put it both, just only down. Okay, thank you. Okay. Nisi Kezia. Yes, Kezia?
Excuse me, teacher. I haven't understood.
From
I
where?
have the work, but I haven't understood.
From where?
I'm requesting you to explain the work
from
to me again.
From where is what I want to know. Hey, okay. Kezia is off. Okay. Emmanuel, your hand is up. Yes, Emmanuel. Yes, Emmanuel. Okay, your network isn't good. Okay. Dennis, you still have something to ask? Dennis, your hand is up. Okay. Okay, so members, this is what we are doing. In summary, please, I want us to keep following slowly. Miranda is asking, is it a must to always factorize a number to its simplest form when working out indices? Yes. When you're working with indices, it is always best that you factorize to its lowest form. It is always far much better that way. Okay, so Miranda, that is what you can do. You're right. That's what you need to do. You need to factorize it to its simplest form. So class, what we are doing, those of you who have maybe just joined and you're not picking it, we are saying that when you have a negative power, always put that power, that negative power is always a fraction, okay? You'll always come up with a fraction. And that fraction is always 1 out of the 4. Like, for example, this one to the power 2. How did we get this? We use the second law of indices. And our second law says, when you have a number to the power m divided by to the a to the power n, what do you do to the powers? You subtract. So you have m minus n. So in so doing, when you follow up this one here, it's that 4 negative 2 is the same as a to the power 0 divided by a to the power 2. Why are we not saying negative 2? Because we are going to subtract. When you say 0 minus 2, this 0 minus 2 is the same as negative 2. Okay? This is negative 2. So at the end of it all, you see that you'll have the same thing as the other side. So that is why we say we divide. When you have a to the power m out of we shall say a to the power 0 out of a to the power 2. Any number of the power 0 is always 1. And that's the reason as to why we are putting it out of 1. Maybe let's give something else here. What if you leave it as 2 to the power negative 4? No, it's not negative 4. Please, you can, someone, where is the Nansubuga Agatha? Can you, where is Nansubuga? Nansubuga Agatha, are you there? Okay. Nansubuga is, so Nansubuga is asking, why don't we say we leave it as 2 to the power negative 4? But we are, remember, we are simplifying it in the simplest form, so that whereby you can no more simplify it. For example, if you have this one here, we know that, remember we are applying indices here. When you leave your answer like this, you may have ended on the way. So that's why you, a person who has studied indices, you know that 2 power negative 4 will be the same as 1 out of 2 to the power 4. This is the simplest form that your answer will be in. So that's why we are using that. Now, in a brief, in a summary form, we have looked at, there's something also I didn't show you here. Maybe let me move back and show you. If you have a number in this form, I don't know if we have seen this. All of us, let's look here. I have this other one here. If you have A out of B and all of them are under a negative power, look here, all of them are under negative 1. All of them are under negative 1. So here what you do, you just interchange them. Okay, just interchange them. This is what you're doing. To do away with this negative here, just interchange. You bring B up, okay, and then the A goes down. This will be a positive 1. This will now be positive in nature. But remember, how are we coming to this? Still, we are applying the second law of indices. Remember, when you have it like this, it is like A is the power negative 1, and also B is the power negative 1. When you apply it, this one will now be equivalent to, this one will be equivalent to A to the power negative 1 is 1 out of what? 1 out of A. Divided by, this one, B to the power negative 1 is the same as 1 out of B. Remember when you remember your multiplication, when you're doing multiplication, when you're dividing numbers, this is what you do. You leave this one, 1 out of A times, you introduce the multiplication, then you take the B up. You bring times B out of 1. So in so doing, you'll end up with what? With B out of A. That's how you're going to come up with this. So once you have this, we are going to see several numbers. So we are going to work out several numbers, but we need to see how they are going to run through. So it will be, if you have A out of B in power -1, it is the same as B out of A. How do you work it out? Bring the power on this negative power on each, both A and B. When you divide, this is what you'll end up coming up with if you're to prove it right. Okay, so that is in the case you have that. Now, we are going, now I said in summary, this is what we have, what we've looked at. I'm summarizing it. There's someone who said he had not looked at the law, first law, second law, third law. Someone is attending for the first time. So maybe you can summarize this in this table here. 1, when you have a number to the power 0, it will be 1. When anything is the negative power, we shall have 1 out of A to that given power. Remember, this is the negative part of it. Then remember when we said, when you're multiplying two numbers, okay, same base, different powers, we add the powers. We remember this. When you're dividing numbers with the same base, different powers, we subtract. Okay, we subtract the powers. That's what we do. When you have numbers, repeat that. Okay, well, I'm going to repeat them. This one here, I said, when you have, let me check out this. We're saying when you have numbers that you are dividing, same base, different powers, and you're dividing, you subtract the powers. Okay, you subtract the powers. This is what we have. Then when you have two powers raised to the same number, you multiply those powers there, and you'll come up with that. Now, this one here, we didn't look at it so well, but this is a simple table that is going to summarize all our work. Now, if you have AB to the power n, look here, it is the same as saying A is to the power n and also B is to the power n. So meaning this n takes up both powers. Then we also said, Jovia is not hearing. All other people are also not hearing. Can I hear those who are here? Can you write, do you type those who are hearing? Maybe Jovia, okay, the others can hear. Okay. So Jovia, check your phone or your computer. Other people are hearing. Eh? Check your phone or computer. Jovia. So this is what we have. Good. Okay. So now let's get back. So we're saying if you have AB to the power n is the same as A, and the power comes in to both the numbers. Okay. Now when you have also these ones here, A out of B and the power is n. Okay. It means this power also goes on to A. It's like if you have A, okay, out of B to the power n. It means this n takes, it means A is to the power n and also B is to the power n. Okay, so that's what you do. That's what we have as in a summary form. Maybe someone has a question on this summary here. Before, I'm going to play for you something that is going to also give us a summary of most of these indices. Okay, let me start with the Sewa Kalyanga Yosia. Yosia, your hand is up, but you're not speaking. Maybe you can speak for this now. Yosia? Yes, Yosia? Okay. Yosia is not ready. Atino? Atino Ashley? Can you unmute, Atino?
Yes.
Your hand is up. You have something?
Not sure. I've understood what you're saying.
Thank you. Misigano. Misigana? Are you there? No? Nyombi? You have a question?
Yes.
Mm-hmm.
I didn't understand here, but the only problem, you removed it.
Which
I
one?
didn't. When they told us, when the question you had, 64 to power negative 2 over 3.
This one? This one here?
Yes.
Now, Nyombi.
Yes, that was
when you
the only problem
Mm-hmm.
and the only problem I had. The method was correct, but when you reached here, when you used root 6 to yes, when you use 6 to power 6 multiply by 2 by negative 2 over 3.
Wait, we said this 64 is the same as 2 to the power 60.
Yes.
Did you get this? Out of 2 to the power 3.
Yes. When you multiply power 6 times the negative 2 over 3. When you divide 3 divide by 6, you get 2.
Now let me listen. You see here, the multiplication is coming from this law. Have you seen this law of our third law?
Yes.
Good. So we are saying we are getting our 2 to the power 6 times negative 2 out of 3. Is this? So we are saying 3 goes here once and then 3 goes here twice.
Yes.
Right? But then 2 times negative 2.
My question was, when you multiply a positive times a negative, they told that it gives us a positive.
No,
but for you say,
no, you get a negative.
A positive times a negative, you get a negative.
Yes, you come up with a negative. That's what we are doing.
Thank you.
Good. Okay, Nyambi has got it. Miss Ghana is there? Yes.
Yeah. I want to ask that when we do the powers, is it must to prime factorize them?
Yes, we are dealing with, remember, indices means powers. Now, when you remove powers, it means you are not dealing with powers. Okay?
So it must to prime factorize them.
Yes, please.
Okay, and I have a second question. What if the bases are different?
Now, when the bases are different, for example, when you have 2 times 3 to the power 2 to the power 3, now this is now different. We're not going to consider these laws here of indices here. Okay.
Yes.
You see that it's the same as you just have you seen this law here? What it's saying? The one of the product, a to the power b power n is the same as a to the power n times b to the power n. It's like you're multiplying them separately and then getting your results. Yes, that is what we're doing. Okay.
Thank you, teacher.
You're welcome. So members, this is what we have, what we can do. Now, let me play for you something here that is also going to summarize for us our work. Okay, I hope we are there. We are winding up. Let's share something here. Okay, I hope we shall be able to see it. Is this? Okay. Okay. Wait a minute. Are you seeing the screen? Students, are you seeing my screen? Okay, yes. Okay. So can you, are you listening? Are you hearing some sound as well? Are you hearing some sound too? Oh. My screen is lost. Are you hearing now? Okay. Are we hearing? Oh.
Indices, the question state without using mathematical tables or calculators.
Yes, we can hear.
So by the end of this tutorial, you should be able to handle any question on indices. So let's start by welcome my viewer. In this tutorial, I will share with you how you can handle this question on indices. The question state without using mathematical tables or calculators, simplify 0.25 to power 2 times 1 out of 64 to power 2 divide by 128 to the power negative 2. So by the end of this tutorial, you should be able to handle any question on indices. So let's start by writing our solution, and we are going to see that our 0.25 is also equal to 25 out of 100 in fractional form, which is equivalent to, if we reduce 25 out of 100, we shall have, by 25 we get 1, and 100 by 25 you get 4, meaning 0.25 is equal to 1 out of 4, which is also equal to 4 to the power negative 1 in index form. Next, let's look at 1 out of 64. That is in fractional form. So in index form will give us 64 to the power negative 1. So let's go and substitute. And then we shall say by substituting we shall have where there's 0.25, we are going to put 4 to power negative 1 in that is squared times 64 now to the power negative 1 to the power 2 outside divide by 128 to the power negative 2. So now let's proceed, and then we said by prime factorizing we need to prime factorize 4, we need to prime factorize 64, and also we need to prime factorize 128. So we are going to see that 4, when we find factorize 4, we shall have 2 times 2, which is equal to 2 to the power 2. Also 64, when we prime factorize 64, we shall have 2 times 2 times 2 times 2 times 2 times 2, 6 times, so we shall have 2 to the power 6. Also 128, let's prime factorize, and we are going to see that it is 2 times 2 times 2, 7 times, so we shall have 2 to the power 7. So by simplifying, now we shall have 4 to the power negative 1, and then to another power 2 outside, we shall have. Now, 4 is 2 to power 2. We are going to multiply by negative 1, and then we are also multiply with the outside power. So we shall end up with 2 to the power negative 4 when we multiply everything in the powers. So also 64 to the power negative 1, and another outside power is 2. We shall have now 2 to the power 6 times negative 1, and then 2 the outside power, that is 2. We are going to multiply 6 times negative 1, you get negative 6 times 2, you get negative 12. So we shall end up with 2 to the power negative 12. Also, let's see 128 to the power negative 2. We are going to represent it by 128 is 2 to the power 7 times the outside power, that is -2. Then we shall end up with 2 to the power -14. So now we shall have everything as 2 to the power -4 times 2 to the power -12 divided by 2 to the power -14. We know that from the law of indices, when we have numbers having the same base, we have to add their powers. So we shall see that we shall get 2 to the power -4 plus -12. We are going to add their powers. So divide by 2 to the power -14. So we shall end up with 2 to the power -16 divided by 2 to the power -14, because -4 plus -12 we get -16. So now let's proceed, and then we say when we are dividing numbers having the same base, we have to subtract their power. So dividing 2 to the power -16 divided by 2 to the power -14, we shall have 2 to the power -16 minus -14. We are subtracting their power 2 squared. So we shall end up with 1 out of 4 as the solution to this challenge. Thank you so much for watching this tutorial. Don't forget to like, subscribe, or comment on my videos.
Okay, so learners, I think we have seen something there that telling us about more about the indices part of it. Someone was saying that I share with you. Okay, I'm going to share with you so that you will try to check it out every time you need it. So okay, now I hope I'm going to, there is a link which is there, so you'll have to follow it up and then you read through. Now I have still more exercises for us. Please, the work that we are now going to have is going to include all those laws that we have looked at in our work. So we are going to have several exercises, but all of them are I'm going to share them with you so that you keep on working them out. But please utilize the laws, utilize all of them. So that's why I want you to have this summary of the table. Please, you take note of this table, a summary, and then when you're working out, you get to know what you're doing following those given laws of indices that we have. There are so many of them. So I'm going to share with you I'm going to share with you in your Google Classrooms, and then you'll be able to get them there. Please make sure that you share with you send me the work after you're done, and then we shall be able to walk through. All right. There was someone who was asking about the Google Classroom. I don't know if Mr. Otto, you're there. Could you please share some? Please, could you
Thank
share
you so
some?
much.
Thank you.
Teacher, we have the timetable. The new timetable do have the links to Zoom and Google Classroom.
Yes. I don't know if others have got the timetable. Some people say they don't have the timetable. I think they're going to share with you here.
Let me try to share it now.
Please do. So learners, just be patient a little. We're going to share with you the timetable and then those links so that in the case of anything, please, you can try to communicate through that. And you can also communicate in case there is anything. You can also get in touch with me through that number. Okay? Through that number. that is in case someone needs to get the corrections. If case there's a question that has failed, please, you can send your details through that number, and then I can easily help you out individually on as we are moving on. Okay, you can always try to communicate through, and then we share. And there are other several numbers that I will be having that I will keep on sharing, and then we shall be able to walk through several numbers. Please practice several numbers. Any numbers, the numbers that you keep seeing having those indices and what, please share with them, work them out. In case you fail somewhere, you try to, in case you fail somewhere, try to ask, and then you'll be given.
Yes, Teacher Moses.
Yes,
I
please.
did not get the link, but I've shared my number. It is on WhatsApp. Let those who are having issues contact me through that number. I'll be able to add them onto WhatsApp group direct.
Okay, thank you.
Any question on Google Classroom, on Zoom, on WhatsApp group, let them just send it to me. I'll be able to guide them.
All right. Okay, so members, thank you so much for attending, and I wish you a nice week. All of you, thank you so much for participating, and thank you for everything. And I wish you a nice day.